Hi, my topic for the project is structural and fatigue analysis of airplane landing gears. So here's the outline, the introduction, objective, model details, results and discussion, conclusion, and reference. So here, the landing gear of a civil airplane is very important because the repeating landing of the airplane may cause the fatigue failure. So the failure of this component may cause the accident and even crash of the plane during the landing. So it is very important to study the fatigue failure of the landing gear to prevent such kind of accidents. So people have have used SEM to examine the fracture failure of the failed aircraft landing gear, and they also study the failure of the landing gear caused by corrosions. So few work has been done on the ANSYS modeling study of the behavior of the landing gear of a civil airplane under cyclic stress condition. So here I use ANSYS to study a very simple model of a landing gear to study stress displacement fatigue and the safety factor distribution under cyclic loading. So this will also simulate the repeating landing condition of an airplane. So my objective is to study the strain stress distribution, safety factor distribution of the landing gear based on the titanium alloy materials, and also the fatigue life of the landing gear under cyclic loading. So here's the material property. I use titanium alloy. So the left hand side is the Young's modulus and also the all the physical material properties from the ANSYS database. And the right hand side figure is the Eisen curve of the titanium alloy. Uh, here is the model detail. So I just cut the landing gear half. So I just use half of the landing gear for the modeling for illustration. So the right hand side figure, this is a meshing of the landing gear. So we have the titanium alloy frame and also the rubber wheels, rubber tires. So here's the boundary condition and also my calculation. So assume the weight of the airplane is about 4 tons. And also I just checked the website and I know that the alloying the maximum landing vertical speed is 1.83 meter per second. So I did two extreme conditions. One is the Vy is equal to 0 and another is Vy equal to 1.83 meter per second. And then I assume the landing time, that when the impact time is t is equal to 0.5 second, and also check the friction coefficient of the rubber is 0.6. So I did the calculation. So the force in the horizontal direction is mu times m times g, and in the vertical direction is mg, which is only the gravity in this condition. And when the Vy is equal to 1.83 meters per second, we can calculate the Fy and Fz based on the equations here. So here's the ANSYS modeling, and the boundary conditions when Vy is equal to 0 I plotted here. So here's a f on the left hand side figure, and the f is bigger for the right hand side figure. And here we can see the safety factor for the Vy is equal to 0 condition. We can see that the smallest safety factor appears here at the top of the landing gear. So it seems that the smallest safety factor is bigger than 2, so this is safe. For the second condition, when Vy is equal to 1.83 meter per second, we can see that the safety factor, the smallest safety factor, still appears at the top of the landing gear frame, and the x is equal to 1.8. So here's the life estimate of the fatigue life estimate of the landing gear. So we can see that the smallest life appears on the tire part. So which means that we need, and however the tire is disposable, we usually replace and change the tires pretty often, so that's also safe for our condition. And here's the stress distribution. We can see that the max stress appears at the top of the also at the top of the frame of the landing gear, and for the Vy is equal to 0 condition, the max stress is about 250 megapascal, and for the second condition, the max stress is about 345 megapascal. So the deformation here, we can see that the largest the deformation appears also on the wheel part here for both conditions. And here's the result. Under the condition of Vy is equal to 0, I can calculate that the force of the vertical direction is 327 Newton, and on the z direction is 24,196 Newton, which is on the horizontal direction. And based on this calculation, the total force is 47,000. And based on the ANSYS modeling, I can observe that the minimum safety factor appears on the top of the frame, landing gear frame, which is 2.7, and the sigma max is 252, also appears here. So the tires have the lowest cycle life, so we need to replace the tire pretty frequently. And also under the condition of another extreme condition of Vy is equal to 1.83 meter per second, so we can see that similarly the y direction force, I mean the vertical direction is the force on the vertical direction is bigger, is 55,000. So the also the horizontal direction force is also bigger, 33,000. Based on those two values, the total force can be calculated to be 64.5 thousand kilonewton. And here the minimum safety factor reduced to 1.9 because the sigma max increased to 346 megapascal, and also the tires still have the lowest. So here's my conclusion. The landing gear is relatively safe under even the extreme landing condition, which has a pretty high vertical landing speed, and also the max stress and the lowest safety factor appears at the top of the landing gear, which is acceptable, and also the tires show the lowest cycle life, so the tires need to be replaced frequently. So here's the reference.